Today we're looking at recurring decimals and how they relate to GPs. Now in year 11 we already learned how to convert recurring decimals to fractions, and the method we used was like this. Let's just say we've got a recurring decimal like this one. We let x equal the recurring decimal, and then I would normally leave a line and then think, well, how can I move the decimal point along so that all the 2's and the 7's will line up? And if they're occurring every second digit or every second column, then if I say x is 0.2727, etc., if I multiply by 100 and therefore would have 100x, then I'm going to move the decimal point along twice, so I'll get 27 point, and then all the 2's and the 7's will continue to line up. Then I treat it like a massive subtraction algorithm and do this whole line minus this whole line. That way I've got 100x minus x is 99x. And over here, all the 7's and 2's going on to infinity line up. So every time you subtract, you get 0, and the 0's go on forever. And 27 minus 0 just gives us 27. Now we've got a simple equation to solve. We can divide both sides by 99 and say that x is 27/99, which can of course be simplified to 3/11. And that's an exact version now of our recurring decimal. But today we'll look at how we can do it another way. Why do we need to do it another way if we already have a method? Well, the more skills and tools we've got in our toolkit, the more capable we are of attacking a whole heap of different types of problems. So now we'll look at another method that we can convert the exact same recurring decimal to a fraction. Now the first step is to think of how you could write it out differently. If the 2's and the 7's are repeating on forever, then if you broke the number up and said, well, we've got 0.27, but then we've got a little bit more. If you thought of the next 2 and the 7, well, they're in the third and the fourth column along from the decimal point, aren't they? And then the next 2 and the 7 are in the fifth and the sixth column along from the decimal point. And you could keep on adding little bits of the number like that forever. So we've got the ... there to show that this is actually an infinite GP. Now, how do we know it's definitely a GP? Well, remember the test for a GP is to say, let's do the third term and divide it by the second term, and that should be equal to the second term divided by the first term. Because if you divide one term by the one before it, that's the same as saying, what have we multiplied this term by to get this one? And if it's the same thing each time, it's a GP. So if we divide this term by this one, or this one by this one, what we actually get is 0.01, or 1/100th. So that tells us, yeah, it is a GP, and the first term, A, is 0.27. Now, you'll notice that this R value is very small. We also know from our last lesson that if the R value is between -1 and 1, then this is a GP that's going to have a limiting sum. And that makes sense. We actually know what the sum of all of these numbers is. We've got a lovely expression for it. We just want a different expression that's in the form of a fraction. So we're going to be using that formula that we learnt, the simplified one, that you use for limiting sums. And when do you use it? Well, you use it when you know that the R value is in that range. So the sum to infinity, in other words, the sum of all of these terms put together, is going to be A, which we know is 0.27, the first term, divided by 1 minus the ratio, which is 1 minus, in this case, 0.01. And you can see there we get 27, we had 27/99 in our last example, 0.27, 0.99, we're getting the exact same thing. And this, of course, simplifies to 3/11. Now, the main way that these sorts of questions get trickier is if they include sections of the number that actually don't recur. So in this example, we've got the 2.6, that's just there all the time, and it's the 4/5 that goes 4/5, 4/5, 4/5 on forever. So if we want to break this number up, we can say it's 2.6, and then to consider the first 4 and 5, well, we know what columns they're in. They're in the hundredths and the thousandths column. So we've got 0.045. And then if you considered the 4 and 5 that came after that, they'd be sitting in the 10,000ths and 100,000ths column. So you'd have 0.3045. And then the next 4 and 5 would, of course, be another 2 columns across from that. And this should be enough for us to see the pattern now. Now, how many terms do we need to see a pattern? Well, to identify it's definitely a GP, you need at least 3 terms so that you can say this divided by that is the same as that divided by that, and that tells you what the ratio is as well in your GP. Now the part that's the GP is this bit, so I'm going to put it in brackets to help me remember that I need to deal with it separately when I'm adding things up. But as with anything that you add up, you can just go ahead and add them. I've got my 2.6, and what I've also got here is I've got, and I'm going to just sort of refer to it, I've got a GP where A is the first term, and the ratio, well, what are we multiplying by each time? Well, everything gets 100 times smaller, doesn't it? Because it moves across 2 decimal places. That tells me I'm multiplying by 1/100th, and that looks like that. So now what I can do is say, all right, I'm adding, and if you want to, you can put your formula in like this on the next line, or you could go straight to subbing it in. Up to you. But I'm making it very, very clear here what I'm doing by pointing out I know I have a GP and I know what the A and the R is, and I've put it in brackets to keep it sort of separate. And now I can say A is 0.045 over 1 minus 0.01. So once I go ahead and put this into my calculator then, I'm going to get 291 110ths. Now, if you put this straight into your calculator and try and get it out as a fraction, of course you can't do it because you can't put your recurring decimal in that way. You could put in a number of 4s and 5s, but you can only fit what you can fit on your calculator screen. Whereas you can put this part into your calculator and it might come up with it when you hit the equals sign as a recurring decimal, which is quite comforting because you know these two things should equal each other. But then when you hit that SD button, it should then be able to convert it back into a fraction, and you need to check that you've got that. And using your calculator is quite sensible because it means you'll get a nice simplified fraction straight away.